Hello everyone. We are now at week 8 of our lecture, which in which we will tackle using loops, temporary tables, and table variables in stored procedures. So first, what are loops? Loop or looping structures allow a single command or group of statements to be executed repeatedly. When using the TSQL while loop, a Boolean condition is checked every time the code within the loop is about to start. If the condition is true, the loop is executed. If not, control passes to the statement following the loop. While loops are commonly used with cursors to process a set of data one row at a time. We will discuss about cursors later, but first let us familiarize with the while loop. The syntax for creating a while loop is as follows. For SQL Server, while condition statement, and then we could place our looping statement inside the begin and end. While for MySQL, while search condition is true, do just looping statement and while. So everything that is inside our statement list for MySQL will be executed as long as the search condition is true. The syntax is the same as the basic syntax for the if statement. The condition element specifies a value, variable, or expression that evaluates as either true or false. If the value is true, the statement part of the command is executed. Once completed, the condition is checked again, and the process continues until the condition is false. Take note that the statement element can contain multiple commands if they appear between the begin and end commands or the begin and end state. The following script declares a variable and initializes its value to 0. The loop condition specifies that the contained statements will be executed while the variable's value is less than or equal to 10. Within the loop, the variable's value is incremented and printed. The end result is that the integers between 1 and 10 are outputted. So this is for SQL Server. We first declare a variable called iteration, which is an integer. We set the default value of iteration to 0, and while iteration is less than or equal to 10, inside our begin and end statement for our while condition, we set the value of iteration to iteration plus 1, and then we print the value of iteration. So this will add 1 to the value of iteration until iteration is greater than 10. So once it's greater than 10, it will exit our statement. But while it is less than 10, it will display the value of iteration. So let us try to execute this one for SQL Server. Again, take note, the syntax for our while loop, while condition is true, inside begin and end, declare your statement. Okay, it's not displaying, so let us try to change the print statement to a select statement. Maybe it's not supporting the print statement. Hmm, not properly executing. So let's try to use our management studio instead. Okay, so notice that we have pasted our code inside SQL Server Management Studio. So once I execute it, the code will be executed 11 times. The reason for this is that first, our first value for iteration is 0. Okay, so it means 0 up to 10. Okay, so 11 times. And then each and every iteration will be printed on our output window. Okay, so we can check 0 is less than or equal to 10. Set 0 is equal to 0 plus 1. So print iteration is 1. Check 1 is less than or equals to 10. That's true. So up until you get a value of 11. 11 is less than or equal to 10, which is false. Execute the statement. There are three loop statements in MySQL. We have the while loop, the repeat loop, and the loop. Okay. The while loop checks expression at the beginning of each iteration. If the expression is true, MySQL will execute statements between the while and the end while until the expression evaluates to false. The while loop is called pre-test loop because it checks the expression before the statements are executed. For MySQL, in this example, we will be creating a procedure called do while wherein we will declare a variable called v1 with a default value of 0, an integer. And while v1 is less than or equal to 10, do the statement inside our while, which is set v1 to v1 plus 1, and then select v1, which will display the value of v1. After executing it, call our start procedure do while. We'll have this particular output. For our online MySQL editor, instead of seeing it vertically, the output will be a little different. We will see it horizontally, but the result is the same. So down below, you can see we have 1, 2, 3, 4, 5, up to 11. That is the output for V1. Okay, so we execute the start procedure with the code. This one. Okay. Next is the repeat loop. For the repeat loop, the syntax of the repeat loop is repeat statements until the expression is false and repeat. First, MySQL execute the statement, then it evaluates the expression. If the expression evaluates to false, MySQL executes the statements repeatedly until the expression evaluates to true. Because the repeat loop statement checks the expression after the execution of statements, therefore the repeat loop statement is also known as a post-test loop. So we have an example here. Create function calc income with a parameter called starting value, which is an integer. This will return an integer. So declare variable income, which is an integer. Set the default value to 0. For this instance, we will make use of a label which will mark our loop. Okay. Um, for MySQL, when we use a label, this will allow us to repeat or go back to the particular label title. Okay, in this instance, label 1. So what will happen inside our label? Repeat, set income is equals to income plus starting value until the value of income is greater than or equal to 4,000. Then end repeat label 1. Afterwards, we will return the value of income. Okay, so let's test this particular function. Okay, so in this instance, we will execute our function called calcincome. Take note, it will accept an integer value for starting value, and then it will loop until the value of income is greater than or equal to 4,000. income, starting value is 0, and then it will add the value of starting value. So once we execute our function using select, take note, this is a function, so we will not use call, instead select because a function returns a value. Okay, to select calc income. So once we execute that, the output will be 4,000. So calc income 500. How about if we set it to 650 will be the value. Okay, the value will be 4550. So that is how you would use our repeat loop. And then lastly, MySQL also gives you a loop statement that allows you to execute a block of code repeatedly with an additional flexibility of using a loop label. In this instance, we will use loop and loop, and then all the statement inside our loop and loop will be executed as long as the condition is true. Now, in this instance, we notice that number one, we will use a label, okay, which will give a name for our loop, just like in the repeat and repeat loop. Okay, so label. So the label name is loop label. Next, we have loop and end loop, which will state the start and end of our statement. Next, we have conditions here. Take note of the following conditions. First, if x greater than 10, leave loop label. So what does this mean? If the value of x becomes greater than 10, we leave the loop. Okay, notice there is no particular condition statement stated on the loop. If we use a loop and loop pattern or style in MySQL, in order for us not to have an infinite loop, we need to leave the loop after a certain condition is met. Meaning to say, if we do not have this one, this will become an infinite loop and your compiler will hack. Okay. After that, we set the value of x is equals to x plus 1. Next, if x mod 2, meaning to say, if the value of x divided by 2 returns no remainder, then we repeat the loop. How do we repeat the loop? Through the iterate command. Iterate loop label. But if not, we set the value of str to str and then concatenate the value of x. And if, again, take note, if we are using loop and loop in MySQL, we need to have a leave loop label, and then we also need to have an iterate loop label. The leave loop label allows us to exit the loop, while the iterate loop label allows us to repeat the loop. Okay, so after doing that, we after executing, and then in the event that the value of x is greater than 10, we select the value of str. So let us try to execute our loop. So the output is 2, 4, 6, 8, 10. Okay, let us again review our code. So the initial value of x is 1 and str is blank string. So x greater than 10 false. X is equals to 1 plus 1, so 2. Okay, 2 mod 2, then, sorry, x is equals to x plus 1. Okay, so set x is equals to x plus 1, so 1 plus 1 is 2. If 2 mod 2 is true, meaning to say if this one or if the value of this one is greater than 0, then we repeat the loop. However, 2 mod 2 is 0, so we execute string is equals to blank, concatenate blank plus the value of x which is 2. That's correct. Okay, and then we go back to our loop. 2 is greater than 10, that is false. 2 plus 1 is 3. So 3 mod 2, that is true. Iterate. Okay. The 3 is greater than 10, that is false. Uh, x is equals to 3 plus 1, so that's 4. 4 mod 2 is equals to 0, so that's false. Goes to else. Concatenate. So 4 is greater than 10, false. 4 plus 1, 5 mod 2 is true. Iterate. Loop again. 5 is greater than 10, false. 5 plus 1, 6 mod 2, so false. So else concatenate 6 up until you get the value of 10. So once you have 10, 10 is greater than 10. Okay, 10 is greater than 10. That is false. 10 plus 1 is 11. 11 mod 2 is true. Iterate to 11. Loop label. So go back. 11 is greater than 10. That is true. Leave loop label. So select str. The value of str is 2, 4, 6, 8, 10. Exiting a loop explicitly. Sometimes you wish to terminate a loop even when the condition part is true. This can be achieved using the break command. Okay, this is good for SQL Server. So take note, this is for SQL Server. For MySQL, if we are to terminate a loop, as you have noticed, we use leave, and if we want to repeat or go back to the start of the loop, we use iterate. The break command specifies that the control should pass to the command immediately following the current loop. In the following script, the loop is calculating the squares of the values between 1 and 99. The if statement checks to see if the result of the square is greater than 1000. Let's try the code. This is a while loop. So we have two variables, two square and square. The default value of the square is 0, while the square is less than 10. Set the value of the square is equals to the square plus 1. Set the value of square is equals to the square multiplied by itself. The value of square is greater than 200. Break the loop and print square. So notice these two lines are part of each other. So the print command is separate. Okay, try to execute. Okay, let us execute our code. Sorry, because we have print statement. It will not properly display here. Right select. Okay, it's still not working properly. So we'll switch to Management Studio. So once we execute our code, notice we will only display, or we will only break out of the loop if the value of square is greater than 200. So if not, we will print the value of square. So up until 100, okay, we we were able to display up until the value of square 100. Anything beyond that, okay, anything beyond that will not be played. And if we try to count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we were able to loop up to 10. How about if we increase the value of our condition to 12? Check. 12 times 12 display about 20. If 20, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It will only display up to 14, not mistaken. Oh, only up to 14 because once you go over there, the 14, we have 15 times 15. So the value is 15. The value already 225. So that is already over our condition. So it will automatically break. In MySQL, leave is used to exit the flow control construct that has a given label. If the label is for the outermost stored program block, leave exits the program. Leave can be used within begin and end or loop constructs such as loop, repeat, and while. In order to use leave, we must place our loop or condition inside the label to tell our code where to exit. In this example, we are using while loop. So while v1 is greater than 0, 2, and while, and then the name of our label. If v1 is less than 3, then leave my loop. Try to execute our code. Okay, sorry. We were discussing this particular part. So leave is used to exit the flow control construct inside MySQL. So it can be used within the begin and end, or can also be used inside loop, repeat, and while. So in this example, we have a label called my loop, which is used for a while to loop or while loop. And then given that if the value of B1 is less than 3, we will execute. label my loop. So let's try to pick a code. So we'll give it a different name because the do while start procedure already exists. Call it do while 2. So in this instance, we have v1 with a default value of 5. If v1 is greater than 0, we repeat the loop. Set the value of v1 is equals to v1 minus 1. So it will subtract the value of 1 for each loop. Then if the value of v1 is already less than 3, we leave the loop and then we display the value of v1. So I'll call our loop. Okay, and the value will become 2. So once v1 is 2, it will leave our loop because 2 is less than 3. Starting a loop. If you wish to terminate a single iteration of a loop, you can use the continue command. This command immediately stops the current iteration and rechecks the loop's condition. If the condition is still true, the loop is restarted. In the next example, the continue statement and break statement are combined so that the squares that are between 100 and 1000 are outputted. So this is for SQL Server. To check if the value of square is less than 100, we continue, meaning to say we will go back to the start of the loop. If the value of square is greater than 200, we will break out of the loop and then print our square value. So the output will be this one. So let us check. Again, for this example, we will be using Management Studio. Okay. So once we have executed our command, this will be the output of our. Notice we did not print the value of square for anything that is lower than 100. What happens is that if the square value is lower than 100, it will go back to the beginning of the loop. Whereas if the value of square is greater than 200, we will exit out of the loop. So for the print statement to be printed, the value should be greater than or equal to 100, but should be less than 200. So that is 100 up to 196. Equivalent to the continue statement for MySQL is the iterate statement. It allows us to skip the entire code under it and start a new iteration. It is similar to the continue statement. Iterate means starts the loop again. So in this instance, we have a label called myLoop for a while to loop. So if the value of v1 is greater than 10, we leave the loop. We increment the value of v1 by 1. If v1 mod 2 is true, we iterate the loop or we repeat the loop to the beginning of the loop label. If not, we concatenate the value of v1 to str or string, and then we select the value of str. So let us check our code. We'll name it to while 3. Then we'll execute our loop. And the output is 2, 4, 6, 8, 10. Okay. How come? Okay. Notice our loop will leave. Our loop will leave once we have a V10. V1 which is greater than 10. So it means it could be at around 11. And then for our V1, with the default value of 0, we will increment the value. Note that every time that V1 mod 2 has a remainder, it will start the loop from the beginning. Otherwise, it will concatenate the value of V1 to str. And then we select or display the value of str. So we have the information here. Nesting. Loops can be nested to provide more complex looping structure. When nesting loops, break and continue commands affect only the loop that they appear within. When breaking out of an inner loop, control passes to the next statement after the inner loop, which will be within the outer loop. In the following example, one loop is nested within another to output the multiplication table for the numbers 1, 2, 3. So a nested loop is the same as any other loop. However, a nested loop is a loop inside a loop. So in this instance, we have a first while loop, begin and end. So that is our outer loop. And then we have an inner loop here, which will print our multiplication table and then increment our condition. Check. Once the condition is true, it will execute. If it's false, it will go back to the outer loop. So let us try to execute this one in Management Studio. Okay, so once we have executed our loop, we will have a multiplication table for 3. Why is that? Our inner loop, notice our inner loop has a condition of less than or equal to 3, meaning once it is greater than 3, it will revert back to our outer loop. For our outer loop, also notice that the condition should be less than or equal to 3. So it will have an initial value of 1 and then up to 3. Okay. So 1 and then that particular value of val1 will be tested inside our inner loop. So 1 times val2 of 1, 1 times val2 of 2, 1 times val2 of 3. Condition false. Go back. Increment val1, 2, 2 times 1, 2 times 2 times 3, so on and so forth. Okay. For our MySQL code, we have the nested loop. Then we have first while start, second while start, first while count, and second while count variables. We have the outer loop here, and then we have the inner loop here. So basically, it's the same logic. So it will check if the first while start is less than the first while count. So 1 less than 3, that's true. So execute the inner loop. Second while start is 1. So 1 less than 3. If that's true, select second while start. Set second while start is equals to second while start plus 1 and then check until the condition is met. So let us try to execute so our output is 1, 2, 3, 4, 5. So let us try to execute this one inside MySQL also. PHP or MySQL Workbench. So if we execute it inside MySQL Workbench, the result can be seen here. Okay, so result 1, 1, result 2, 2, result 3 is 2, result 4 is 1, 2, 3. Okay. SQL Server cursors. So a cursor is a database object that permits the data set generated by a query to be processed one row at a time. So basically, you could think of a cursor as a pointer wherein you can get each and every row of your generated data. Okay, that is a cursor. It provides a pointer to a single row and allows the information in that row to be extracted and processed. Once that processing is complete, the cursor can be moved to another row. This allows row by row processing that may be difficult to accomplish using other techniques. Commonly, a cursor is combined with a while loop to enable row by row processing of an entire dataset. In such cases, the while loop uses a cursor status function to determine whether the end of the data has been reached. If it has, the loop exits. If not, the next row is retrieved or fetched from the cursor and the loop restarts. Now, what are the considerations? Some developers and database admin dislike database cursor because they use resources while they are open and read data from the database each time a new row is fetched. This can increase network traffic, lower the available resources of the SQL Server instance, and lead to poor performance. However, cursors can be useful when row by row processing is required, particularly within stored procedures that do not return the data. So, so do not generate excessive network traffic. As with all development techniques, you should consider all available options and select the most appropriate for the situation. As a rule, whenever a certain process uses a row and takes up a long period of time before executing, try to make use of other looping techniques and see if it will improve the system performance. For this example, we are going to make use of two tables, table Pokemon and table region, having this data. And first, we create a view called view Pokemon, wherein we get the Poke ID, Poke name, and region name from table Pokemon and table region. So once we have created our view, we will declare our cursor. The syntax for declaring a cursor is declare cursor name, cursor for, and what is the query you are getting. So in our example, we will make declare Poke cursor, cursor for select Poke ID, Poke name, region name from view Pokemon. How do we open a cursor? To open a cursor, we use the open cursor name command. Once a cursor is open, you can determine the number of rows it has using the at cursor row function. Print at cursor rows function will output 4. How do you get the data from the row? To get the next data, you use fetch next from and then cursor name. The cursor declared above is only a forward-only cursor, meaning you could only move to the next record. It is only possible to advance with the rows one by one. It's not possible to jump to a specific position, skip rows, or reverse through the data. As such, there's only one available command that can be used to obtain a row from the cursor, which is the fetch next command. If you execute this command from SQL Server Management Studio, you will see the first row of data displayed in the results area. Each subsequent execution of the fetch command returns the next row until the cursor is exhausted or the entire row has been transversed. Closing a cursor. Once you have finished working with the cursor, it must be closed to free up the resources associated with it and to clear any locks that the cursor has created. To close the cursor, we use the command close and then the cursor name. After closing it, we also need to be deallocating the cursor. A closed cursor can be reopened and reused multiple times. This is because the data structure of the cursor are not released when the cursor is closed. Take note, the data structure of the cursor is not released when the cursor is closed. To release this structure and destroy the cursor after closing, you should deallocate it using the command deallocate cursor name. Now, how do we retrieve the cursor data into variables or inside variables? The example above is interesting as it shows the use of a cursor. However, in a real-world situation, it will not be particularly useful. Generally, you wish to fetch the raw data into variables that can be used for further processing. For example, we require five variables for the five columns in the query. In this example, we have three. So three variables for the three columns that we have in our view. Declare the variables as follows. So we have the three variables PokeID at PokeName at region name that will get the data that we have extracted from our cursor. To fetch the data from the cursor into the variables, you use the into clause. The clause is followed by comma-separated list of variables to be populated. The first variable will receive the first column, the second variable, the second column, and so on. One variable must be supplied for each of the queries column. So notice because we have three columns that was placed into our cursor, we also need to have three variables. Looping through all data in a cursor. Cursors are commonly used with while loops to process every row returned by the query individually. The first fetch operation is performed outside of the loop. This obtains the first row, one is present, and sets a flag that specifies whether the cursor is exhausted or if further rows are present. The flag is accessed using the at fetch status. At fetch status returns either true or false if there is still a record from our cursor. If the fetch successfully found a row, the return value will be 0. Okay, so meaning if at fetch status is 0, it means there is data or there is a row that was retrieved. If not, then or if it has a different value, then it means there was no data that was retrieved. While loop can use this function to determine whether further iterations are required. Okay, so if at fetch status has not received or the status of our at fetch status states that there is no more data, we will stop fetching from the cursor. To demonstrate, execute the following batch. This loops through all of our data to simulate the integration to the third-party system. Information from each row is outputted to the messages window. So in this example, guys, we will make use of SQL Server Management Studio because of the print statement. This will not properly work on our online editor. Okay, so we have our shared procedure PR poke name, which will output our ID, name, and region name. So let us step through all of the code. Create procedure PR poke name as begin and end, which is the beginning and ending of our code. So all of our statements inside the start procedure will be executed. First, we declare three variables, Poke ID name and region name, integer and character, varchar. Next, we declare our cursor called Poke cursor for a select statement on our view Pokemon. We get the Poke ID, Poke name, and region name. After that, we open our cursor. Next, we fetch next from our cursor so that we can get the value of our columns into our variable. Take note, depending on how the columns are ordered, should also be how your variable should be ordered. A integer, integer, string, 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 string. And then using while at fetch status, we check if there is a row that was retrieved from our cursor. If it has, because our at fetch status return 0, we print the value of our Poke ID plus the Poke name and the region. After doing that, again, we perform a fetch next, and then we set the value into our variables. After doing this, it will go back to the while at fetch status and check if there's still record. If there's still record, all of the statement will loop. If there's no more record, we close the cursor and then we deallocate it. Let us now execute our stored procedure. So this will become our output. Okay, let me increase font size so that you can see. Okay. Also have what we call insensitive cursor. By default, cursors read each row of data from database tables are as required according to the query that is specified. If the data is modified after the cursor is opened, the modified data will be presented when fetched. If a user has deleted rows, this will not be accessible via the cursor. In some situations, this is undesirable, meaning our current setup for our cursor is actually sensitive. If there are any changes or if there are any removed rows, it will also be reflected in the cursor even after that changes were made after the cursor was opened. Now, in order to circumvent this problem, we can use an insensitive cursor. An insensitive cursor is not affected by the changes to the underlying data. When the cursor is opened, a temporary table is created in the TempDB database. This table is populated with the result of the query immediately. Once populated, each fetch retrieves information from the temporary table rather than the live data. To specify that the cursor is insensitive, add the insensitive clause immediately after the cursor name in the declaration. So for example, if we want to make our cursor insensitive earlier, we just put the keyword insensitive before the keyword cursor. We also have another example here for our cursor. This example, we have two tables, table employee and table worker. We will use a cursor to transfer data from the table employee to table worker and get the daily, hourly salary rate of the said employee. Also, worker's quarters value will be based on what quarter the employee birth falls. So for this start procedure, we will declare one, two, three, four, five, six variables: the name, the monthly salary, the daily salary, the hourly salary, the birth, and the quarter of the birth of the employee. We declare cursor called worker cursor, and then we select the name, monthly salary, and the birth of our employee. We open the cursor, and then we fetch data from our cursor, and then we place it into name, monthly, and birth. So our loop will be like this. If the month of the birth is less than 4 and greater than 0, we set it as a first quarter. If the month of the birth is less than 7 and greater than 3, the quarter is 2. If the month is less than 10 but greater than 6, the quarter is 3. And if the month of birth is less than 13 but greater than 9, the quarter is 4. After doing that, we insert our data into table worker. The worker name will come from the at name. The worker daily wage is the monthly divided by 26. The hourly wage will be monthly divided by 26 divided by 8 hours. And then we display or set the value of our quarter. After doing that, we again fetch the next employee into our cursor and check if there is data. If there's still data, we execute the code again for the next employee. If none, we close our cursor and then we deallocate our cursor. So let us try to check if our cursor will work using our compiler. Except so this should transfer or display data from our table employee to table worker. So let us check our table worker if the data has been moved there. Okay, notice the data has been transferred. So what I'm going to do is to delete all the data from our table worker and then execute the start procedure again so that you will see that it works. Okay, table worker has no data. Execute start procedure again and then display our table. Okay, and that is the result. And that is how you would use a stored procedure and a loop and a cursor in order for us to uh, insert data from one table to another and then process that particular data. Next are temporary tables. The temporary tables can be used for all database management system, whether it be SQL Server or MySQL or Oracle or MariaDB or all the other RDBMS. Temporary tables are supported. But for this example, we will focus on SQL Server only. Temporary tables are a special type of table used to hold data temporarily. It can be used when performing complex operation that, if executed against live data, could affect performance for other users or could lock rows for an acceptable length of time. They are often created and populated with a copy of the data to be processed. Once activities that require them are completed, they are dropped. They can either be local or global. A local temporary table is visible only to the session that is created from and is dropped automatically when the connection is closed. Other users cannot access the table, although they may create their own temporary table with the same name. In such situations, the two temporary tables are in no way linked. Global temporary tables are available to all users and are automatically dropped when the last user accessing the table disconnects from the database. Although both types of table will be automatically dropped, it is common practice to delete them manually when no longer required. When a temporary table is created, a physical table is created in the TempDB database. This table has a name similar to that specified, but that is slightly modified to ensure that it is unique. This allows two users to apparently create two temporary tables of the same name. When information is added to the table, it's added to the physical table in TempDB and written to the disk. The performance of a temporary table is therefore similar to any other table. To demonstrate the use of temporary tables, a stored procedure will be used to obtain the Pokemon name, ID, region, and region 9 from table Pokemon and table region using the created view of view Pokemon we had earlier. Creating the stored procedure. So the stored procedure will be named create procedure PR Pokemon temp. Some variables are required. So we have three variables: ID, name, and region name. Creating the temporary table. The next step is in the start procedure is to create a temporary table. The table will hold the Pokemon ID, name, and region name for every Pokemon. This information will be populated in further steps before being selected as the procedure's return dataset. Creating a temporary table uses the same syntax as to create a standard table. To signify that the table is a local temporary table, a hash or pound symbol is used as a prefix to the table. The name may be up to 116 characters in length. So in order for us to signify that a table is a temporary table, use the hash per pound sign before the table name. So we will create a temporary table called Poke, which has ID, name, and region, populating the initial data. To initialize the data in the temporary table, we will copy all information from the live data. So using, so we will insert into our temporary table the ID, the Pokemon name, and the region name from the Pokemon. Next, we declare our cursor called PokeCursor. So using the data that we have inserted from table Poke. Next, we open our cursor, and then inside our while loop, or before our while loop, we fetch our data to our variable, and then inside our while loop, we will print our ID, name, and region. So basically, it is the same as the start procedure that we have created earlier. However, we will be using temporary table here. After doing that, we again fetch our variable and check if it has data. If it has data, it will repeat the code. If not, we close and deallocate our cursor. After doing that, we must not forget to drop our temporary table. Okay, although this temporary table is automatically dropped, it is advisable or better to manually drop the table once we have no more used for it. Okay, so we will now try to execute this inside our online compiler. Now here are complete code. So PR Pokemon temp, three variables, Poke ID, name and region, temporary table Poke, having Poke ID, Poke name and region. Insert into our temporary table the data from our view Pokemon. Next, we create our cursor using the data from our temporary table. We open our cursor and then we fetch the data from our cursor into our variable. Using a while loop, we check the status. If there's a record, we print the data that we have gotten, and then afterwards we fetch again our cursor into our variable and then repeat the loop again until there's no more record that was fetched. Afterwards, we close and deallocate our cursor and we drop our table. So let us try to execute our third procedure. Okay, so our view Pokemon is missing. So we pick that one, our view first. Okay, then execute our third procedure again. Okay, and sorry because we were using the print statement. So if in order for us to use this one, we need to use Management Studio. So using it will have almost the same output as earlier. So that is how you would use a temporary table. Usually, temporary table are used for reporting and processing purposes. Next are table variables. So table variables provide functionality similar to a standard variable and a local temporary table combined. Standard variables are used to temporarily hold a single value within the scope of a script or stored procedure. Temporary tables are used to define an entire table stored in the TempDB database for the period of some process. Table variables are variables that have a specific scope and permit a table-like structure to be constructed and populated with many rows of data. Table variables are often used where a table variable would be utilized otherwise. Their primary use is for storing information that is to be returned from a user-defined function. However, it is not uncommon to see table variables used within stored procedures, triggers, etc. In such cases, the variable exists only within the scope of the procedure. When the process terminates, the table variable is automatically destroyed. It cannot be passed into an input parameter of another procedure or returned as an output parameter. It if data needs to be returned by a stored procedure, the variable would need to be queried before the procedure ends. Table variables may be stored partially within memory or in the TempDB database if an APRAM is not available. They use fewer resources for locking and logging than temporary tables and are not included in transactions. Can provide improved performance when compared to a temporary table, but that does not mean the table variables are not affected when a transaction is rolled back. However, as table variables cannot have explicitly declared indices, they do not have parallel execution plans and are excluded from statistics gathering. Performance can be lower than the equivalent temporary table. Table variables tend to be better for small sets of data or when the queries executed against them are not complex. Temporary tables often increase the performance for large data sets and complex ad hoc operations. To determine which To use for a given scenario, you should implement both and measure the performance before selecting an approach. To declare a table variable, the syntax for declaring a table variable is similar to that of creating a table. The declare statement is used to name the table variable, and the column names and types are included as a comma-separated list within the parentheses. The following sample code declares a new table variable with two columns. So declare at tv table. So the data type is table. The variable is at tv. We have two columns, ID and name. Adding data to a table variable. Once a table variable is declared, information can be inserted, updated, deleted, or queried as if the variable were a true table. The following inserts two rows, updates one of those rows, and then executes a query against the table variable. The script must be executed in the same batch as the previous declaration to operate successfully. If the declaration executed alone, the variable will be out of scope before the data can be manipulated. So table variables can be inserted, updated, select, or queried upon, or even deleted. Adding other table features. Table variables can include many table features, including primary key, unique key, constraint, identity, and default value. Each is declared using the same syntax as for a true table. In the following example, the table includes a primary key. If you run the script, you will see that the second insert fails because it would require the creation of a duplicate primary key. So in this example, once we execute this query and then execute this second query, the second query will encounter an error because we have already have a primary key of 1. So in this instance, we will update our procedure PR Pokemon temp, name it PR Pokemon temp 2. But this time, what we will do is to make use of a temporary table called at Poke. All the output and the process will be the same except for the use of table variable. So notice we declared, we inserted the table variable, and then we called our cursor using the table variable data. And then we have here an extra code. Notice I selected our table variable and then I ordered it by PokeID. So this will print our output, but at the end of the third procedure, this will also display all the contents of our table variable ordered by PokeID. So what I will do is try to run it in our online compiler. Code here, table variable, create value, and prepare our cursor for data. So this print will not be displayed because our online compiler does not support the print command. However, this will display all the contents of our table variable before the end of our stored procedure. So let us try. Trying to execute it. And there you have it. So this is the output of our table variable. So temporary table and table variable are almost the same. However, take note that they have a difference in syntax. Particularly, temporary table uses pound or hashtag, while table variable uses the variable name. Usually, I use the at sign. And then also temporary tables, you have as much as possible, you have to manually delete it uh, before the end of the stored procedure. But for table variable, we do not need to delete it because once the execution is finished, the variable will also be gone. Okay. So please check on what particular situation you can use the two because sometimes there are instances where a table variable can be faster than a temporary table. So that is all our lecture for this midterm. Thank you.